Alright, let's go over, or let's look at answers to the worksheet on differential equations. Assign the odds for 1 through 11, and then 12 through 16. So number 1, dy dx equals x squared over y. Y equals negative 5 when x equals 3. So I don't know, I prefer to see it as a point, so I rewrote that as a point. Separate the variables, so move the y over, move the dx over. Integrate both sides. So y squared over 2 equals x cubed over 3 plus c. And this is where, do I want to solve for c now? Do I want to do some algebra first? I guess I'll do some algebra first. So let's multiply through by 2. Y squared equals 2/3 x cubed plus c, because 2 times c is still just c if we don't really know what c is yet. Square root both sides. And when I square root both sides, I need to put a plus or minus on there. But I need to be careful because I don't know which one it is. So maybe that'll come up in a minute to figure out if it's excuse me, positive or negative. So I've got it solved. It's not plus and minus because then it wouldn't be a function. It's plus or minus. And maybe this will help me figure out which one it is. I think I just got my answer. If negative 5 goes in for y, it's going to have to be the negative one. 2/3, 3 cubed, plus c.
Bless you.
Thank you. So negative 5 equals negative square root of, let's see, 27 divided by 3 is 9, times 2 is 18. The negatives will cancel, so 5 equals, actually be careful with canceling the negatives. I need to make some note that I'm picking the negative, not the positive, to make this work. So 5 equals the square root of 18 plus c. So c's got to be 7 for that to work. 7 plus 18 is 25, so c is 7. So y is the negative square root, 2/3 x cubed plus 7. Common mistake on that one is that negative thing. But the only way it will work is if it's negative. So hopefully you remember the plus or minus back here and then put the negative on. Number 3. dy dx equals 1 over y squared, and y of 0 equals 4. So separate the variables. Y squared dy equals dx. Oh, this is going to be an easy one in terms of separation of variables. Or in terms of, separation of variables and integrating. Y cubed over 3 equals x plus c. So y cubed equals 3x plus c. Different c, but unknown c times 3 is still unknown c. So y is the cube root of 3x plus c. And if we plug in 0, 4, let's see, let's cube both sides. And we cube both sides, c is 64. So y equals cube root of 3x plus 64 for number 3. Number 5. dy dx equals negative xy squared. Y of 1 equals negative 0.25. Separate variables. dy over y squared equals negative x dx. I don't really want to integrate that like that because I'm afraid I'm going to mess it up. So I'm going to do, y to the negative 2 dy equals negative x dx. So increase the power by 1, divide by the new power. Same thing on this side. Oh, this one's going to have some algebra in it. 1 over y. I'm going to multiply through by negative. And again, c. So those are different c's, but it's still an unknown c, so I don't have to worry about it. I would like to flip both sides of this, but I can't flip this side until it's has a common denominator. So I'm just going to put it over 2, and that changes c again. But I still haven't decided or haven't assigned a value to c, so I can do that. So 1 over y equals x squared plus c over 2. Now let's flip both sides. So y equals 2 over x squared plus c. And now we know, or we can use, x is 1, y is negative 0.25. So negative 0.25 equals 2 over 1 squared plus c. Let's see here. Let's cross multiply. Let's do that. So negative 0.25 times 1 plus c equals 2. I think I want to rewrite that as negative 1/4, because then I can multiply by negative 4 on both sides. And so I get 1 plus c equals negative 8. So c equals negative 9. So y equals 2 over x squared minus 9. That was a lot of algebra, so I want to quickly check to make sure this still works. If I plug in 1, 2 over 1 minus 9, 2 over negative 8 would be negative 1/4. So I feel a little bit better about number 5. Number 7. dy dx equals 4x cubed y. Y-intercept equals 7. Well, that's just a cute way of saying 0, 7 is the point that we're concerned with. dy over y equals 4x cubed dx. Integrate both sides. So this would be natural log of y equals x to the 4th. Yeah, the 4's would cancel. Plus c. So we've done this one a couple times now. We did the loop-de-loop thing. E to the x to the 4th plus c equals y. And then we do our little algebra trick. C e to the x to the 4th. That's a different c than these c's. And we'll use 0, 7. So c is 7. So y equals 7 e to the x to the 4th. What a lovely answer that is. Again, I could check it in there and make sure it works. That's an easy check. It works for that. If I wanted to, I could check it in here, and it really wouldn't be that bad. Because if I take the derivative of this thing, I'm going to get, you know what, let's do that. The derivative would be 7 e x to the 4th times 4x cubed, chain rule. And well, 7ex to the 4th is y. And so it does check out. So you can check these. I wouldn't check very many of them, but it's an option if you want to. Number 9. dy dt equals negative 3y. 0, 1. And then, this is has an extra step in it. Find t when y equals 1/3. So there's a lot going on in this problem. Let's see, so dy over y equals negative 3 dt. It's another natural log problem as well. Natural log of y equals negative 3t plus c. So e to the negative 3t plus c equals y. We do our little algebra trick. C e to the negative 3t. And I can figure out what c is based on 0, 1. So c is 1. So y equals 1 e to the negative 3t. And now I want to find t. So that's usually where we stop. We usually stop right there and we're good. But this one asks me to find t when y is 1/3. So 1/3 equals e to the negative 3t. Ugh, logs again. Because the way I'm going to get that out of the exponent is to log both sides. Natural log of e is 1. So t equals natural log of 1/3 over negative 3. And there's probably some properties of logs I could do with the negatives, but let's just leave it alone and call it good. Number 11. I started number 11 in class with some of the classes. F prime equals 2 times f of x. F of 2 equals 1. F prime is a nice notation, but it doesn't really help me here. I think it would be nicer if we wrote this as dy dx, and if we wrote f of x as y. So dy over y equals 2 dx. Another natural log problem, which means another e problem when we do the fishhook thing. So y equals c e to the 2x. And now I need to use the 2, 1. So y is 1 when x is 2. It's going to be kind of an ugly c value, but that's okay. So y equals 1 over e to the 4th times e to the 2x. That's a okay safe stop, but properties of exponents for a multiple choice test is probably going to be e to the 2x minus 4. Alright, I'm going to stop there. Answers to the rest are posted online. So hope you watched it. Hope you learned something. Good luck on Friday.